Hi everyone, this is Kevamshi from EC section and having the rule number 209518047. So today I want to discuss about the Samsung M3 processor, which comes under the topic of microprocessor microcontrollers. Let's getting into the topic. So coming to the introduction, the M3 processor it's a third generation processor of Sam, Samsung. So it is a custom microarchitecture processor, and performance depends, continue to grow and major design improvements are required. So in this generation, the core is enhanced with a 6-wide micro architecture and deeper out of order resources and faster instruction. So inst- uh, apart from the M1 and M2 processor, it has a faster reactions and 6 wide micro architecture, and core is enhanced than M1 and M2, and M3 delivers a new level of performance to the Android ecosystem. So power efficiency was prioritized over absolute power. Since M1 and M2 are two processor which consumes more power, but as a part of improvement, we need to consider the use of power. So M3 processor were designed in keeping sense of power usage, and area growth was a concern, but acceptable if good performance gains should be shown. So since Samsung asked R&D sensor, which is known as SARC, started building processor initially with M1 in 2002 2014 and M2 in 2015, and finally M3 was improvement of M3, and which came into the work from 2018. So Samsung company which is known as Sark Industries. It started building its own processor like M1 and M2 and M3 from the 2014 and 2015. In the overview of M1 and M2, they provided good work, but there is a need of improvement in both cases, in the way of power efficiency, fast instruction, architecture wise, and many things. So finally, they came into M3 processor, which came in work from the 2018. And coming to the performance of the M3 processor, the performance analysis effort for the M3 processor was broken into three phases. So it can be decided the performance of M3 processor by three techniques, like each of which require different abilities from the analysis team, like early trial blazing or feature mining and implementation trade-offs, and final correlation, or also known as polish. So here you can see the M3 core block diagram of Samsung M3 processor. Like it includes front end, mid core, load and store, and floating point. So in the front end, we can see the branch prediction and add a queue and 64 KB cache and insert queue. And coming to the mid core, you can see the decode, rename, retire, branch, and division. And coming to the load and store, you can see the 60 by decode cache. And coming to the floating point, you can see many unit it consists. So the M3 processor is designed for the flagship Samsung smartphones. So it is designed for the only flagship Samsung phones, and building upon the prior designs, the M3 has widened the bandwidth, deepened the out of order window, and improved latencies in both core operations and cache hierarchy. So the prior designs of M3 was to increase the wide the bandwidth and out of order window, and improved like latency should be reduced in both cases. So M3 has high latency reduction in core operation and cache hierarchies. So coming to the part one, like front end. So the microarchitecture of M3 branch predictor and instruction cache was conceived considering three classes of application. Like it has small corners that fit in micro branch target buffer, which is known as BTB, and moderate size application that fit in main BTB, and large application that get coverage from a L2 BTB. So these were the three small applications included in front end. Like a small kernel should be fit in micro BTB, and moderate side fit in main BTB, and large application will fit in L2 BTB. It is a hierarchical approach, allows trade-offs between capacity, latencies, bandwidth, and power. So coming to the another part of midcore in M3 Samsung design, the MC refers to the section including instruction, decode, rename, dispatch, the integer schedule register, file execution, and the retirement blocks. These were the small some instruction included in midcore, like decode, rename, dispatch, and integer schedule, register, file execution, and retirement blocks. And these blocks were redesigned for the increased bandwidth and out of order capabilities, as well as instruction latency reduction. So as we discussed earlier, it uh, it has a high reduction of latency, and other capabilities are also bandwidth also increased. So coming to the load store unit, the major improvements of M3 LSU can be categorized by bandwidth improvement and increase out of order capabilities and capacity latency improvements. Coming to the last part, like floating point unit, the FPU handles floating point and SIMD, including vector integer instruction in a process style design. So the design has been widened to sustain up to 3 ops per cycle. So like dispatch, schedule, and execute versus 2 in M1. In M1, M2, we can have two OPs to execute, but in M3 you can find dispatch, schedule, and execute. These were performed in one per cycle. The primary exception to a pipeline and nature of FPU is defined unit, and the redesign of the floating point divider to a radix 64 algorithm allows computing of 6-bit per cycle of a result. A increase 3 increase over the older radix 4 design. So here you can see the comparison of M1 and M2 with M3 CPU cluster organization. So in the M1 M2 cluster, you can find L2 CPU1, CPU2, CP not CP3 depend on L2 CT control, but each has divided into each section in M3 cluster. So coming to the final conclusion, the smartphone technology is advancing rapidly, and competition is not standing still. So to service the annual cadence of the premium smartphone market and to provide customers with better experience, except SARC to deliver competitive CPU performance, uplifts and efficiency improvements every year.